Good day, everyone. Thank you for joining. Today, me and my colleague are going to be talking about the workload migration and more specifically, the VMware to Mirantis OpenStack for Kubernetes. We're going to be talking about how we address these problems and basically walk you through the process. I'm Michael Tillman. I'm a principal architect, been with Mirantis since about 2016, and I've done multiple webinars related to infrastructure, OpenStack, and Kubernetes. I'd like to introduce my colleague, Heiko Kramer. Heiko, if you would please introduce yourself.
Yes. Hi guys, I'm Heiko Kramer, also principal architect. I'm working since 7 years for Mirantis now, and actually coming also from the world of cloud architecture, operations, workload migration, also thin layer in between. Actually, I started with Cloud Foundry back to these days, and so yeah, and now I'm here and. We are presenting to you how we in Mirantis want to migrate the workloads off from VMware to OpenStack.
Considering a cloud transformation or migration? Check out the Total Guide to Private Cloud from Mirantis to learn how open source cloud on-prem gives you cloud benefits without the downsides. Download now at mirantis.com/privatecloud.
Just to dive straight into it, why are we here today? And there's a couple of things that we want to talk about, and that's is VMware still right? Is it still the correct solution for us, for you as an organization, for your workloads? And if it's not, then you need to be able to find another solution. And in order to do this, you need to understand what you can migrate to, what are the solutions, and how easily you can get from to be able to migrate off of VMware onto a different platform. And what we're here to discuss today is actually that the Mirantis solution is a viable solution for that, and how you would migrate off of your VMware ecosystem right now onto the Mirantis ecosystem. Basically, what are we trying to solve, and what are we trying to do, and how are we trying to do it? So we need to be able to move these workloads, and more importantly, the data from VMware to the Mirantis OpenStack. And so the workload owners, often they don't have the time or the resources to be able to do this effectively. And you need a migration plan, and you need a solution where your workloads, they are unique, but you need to have a solution that will drive you into this new ecosystem. You also need this idea of automation where you can do the deployments and the maintenance, and where is automation available. One other thing is the external third parties, the services. You need to be very involved, and they very, quite frankly, lead into the dependency on those. So we're trying to solve these very distinct problems, and how we're going to address them is going to be addressed in this webinar. So right now, currently in the industry, there are 3 strategies available that you can look at. There's the replatforming, the rehosting, and the refactoring. Now, these are very highly dependent on the workload types, and they require a very well described and defined process. And so what we can do here is take a look just real quickly on the right-hand side here and talk about what all is going to need to happen in order to take place. And it's I'm not going to walk through each one of these, but basically it's discovering and prioritizing these workloads, then determining the migration path, and then from there we'll go into a couple of different options, and that is the rehosting on the top. There is, after you've determined the migration path, you would of course start the migration using a migration tool, and then into validation and the deployment into production. Now, from the replatforming perspective, you would see after the migration plan has been established, you would determine and adjust the platform and validate the workloads that are going to be migrated. And then, of course, this flows directly into validation and then the deployment into production. On the refactoring side, what we can look at now is the scanning of the workload, the architectural and code changes that are associated with that, and then the LCM updates directly into the validation and then deployment into production. Very high level, and my colleague is going to dig deeper into this as we go. So how does Mirantis approach this? And there's of those three previously mentioned that we do is we have VM to VM, which is rehosting, replatforming, and the migration of the virtual machines utilization is those three pieces there: the snapshot, replicate, update, and cutover. These are just a very high level view of how we would address each of these from the rehosting and replatforming from VM to straight VM. The VM container and modernization or replatforming, the migration of those virtual machines to containers. It utilizes a proven self-service software solution. We also, it allows for the application owners to assess the viability of those workloads and the components of those workloads. And then we create the necessary container artifacts, including the images, Docker files, Helm charts, etc. Then also for the refactoring portion, we have the Mirantis PS Consulting, where we would basically refactor the applications into microservices. We can deploy onto the container platforms. And, of course, there is no, when there is no partner or tool available, we can do this through a PS Consulting. So what are the approaches? Let me give you the high-level pros and cons for the V2V automation, and that's the VM to VM. It is a warm migration, and these are the pros, of course. The end user and operator UI, we have that as well. We have the entity mapping and configuration settings. We speed up the data transfer, and it's all done at scale, at a very large scale. The visualization of the migration plan, we provide those as well, a very documented procedure. And the one con on that is it's individual settings per VM are required because of the application specificity. Now, the containerization, we also provide the operator and end user UI. We have again, it's done at a very large scale. Automating is very important as part of our process, and it can and always does lead to a much smoother and cleaner migration. The self-service again by the customer is also possible, and the one con here is that no data migration is not included. So now the modernization is again done by professional, skilled engineers that have done this time and time again at scale. We have multiple teams. We have using your on-site expertise as well as our expertise. And there's a comprehensive plan and the prioritization of those components that we do need to refactor. Again, it is a modern and sustainable architecture that we provide to you. And the two downsides that we've noted here are, it's viable for highly business critical workloads and long running processes. So now I'm going to turn it over to Heiko, and Heiko is going to walk you through how the actual migration process works and dive deeper into the above three that I just mentioned, those three different use cases that we're going to describe today in detail.
Thank you, Michael. Hopefully everyone can hear me well again. Of course, every migration relies on a good planning. I think everyone can agree on that, especially when it comes to large migrations, when you want to get off from VMware and you have a couple of E6i hosts with a couple of rich machines. Then it's I think a good idea to plan it, right? So and that is exactly what I want to go through, because the planning phase is very important. So we have here a couple of phases. Typically, so we are together with you guys, we are creating a governance team with a weekly thing typically, and that we can move forward and address issues very quickly, so that we have an agile process to react on workload issues, maybe after migration, or even failed migrations, that we can handle that. So, but one thing maybe in addition, this is for sure optional, right? So the solution actually provides you also a self-service, fully driven by you. It's up to you if you want to plan it by yourself fully, or if we do this together in an efficient way. So the first step is for sure discovery. So discovery means here we're scanning the source platform. We are discussing with you. You see here discovery and planning is actually one box. It's migration workshop. It's one thing what we are offering, again, especially for large migrations, because we are speaking there about the solution, about the process, about what is currently on the source side involved, what services are involved. So we are creating a service parity list. We try to explain, and that is also important. I will come later to that again, but just to highlight is for sure, if you are moving away from VMware to another platform, and it doesn't matter which platform, but today we are talking about OpenStack as target, or and in this regards, you cannot easily migrate all entities, right? Because the majority of entities, what is available in OpenStack, are not available in VMware. For instance, I give you an example: images, right? You have a template system, you have a disks, but you don't have a base image where all virtual machines rely on, or not all, but what you choose. So these kind of things we're discussing in the workshop. Make a plan for the migration, which suits to your corporate as well, because for sure every enterprise works differently internally, from the communication perspective, from the information perspective, and so on and so forth. So all this needs to be adjusted and defined before we actually start the migration. The next step, typically this takes 2 weeks, but again, it heavily depends here on the size of the migration. For sure, we don't require 2 weeks of planning when we talk about 400 or 500 virtual machines. That doesn't make sense. But when we talk about 10,000, 20, 50,000 virtual machine, then definitely we require some time also to define and agree with you guys the different milestones and how we handle that and what workloads we want to migrate first. The next step would be we have somehow of a migration catalog then. The next step would be to deploy everything on your environments. So that means we are deploying the agents on the source side and the engine on the target side and preparing the system, right? And then actually we start fully automatically the predefined migration plans. These plans are well defined in migration windows. The thing is, the initial replication so is actually doesn't matter when it starts, right? We just need to take care at this point of well, that you don't disturb someone else, right? The bandwidth or storage utilization or something like that. And at the end, we are at the validation phase. As I already mentioned, we have discovery and planning phase, right? And also we have at the end some deliverables. So after discovering, as you see, we have application portfolio. It's actually just a list with a couple of information what is currently running. For sure, maybe application is here a bit misleading because we have no clue about the workload, right? We just look from the outside what is running. We know there is a virtual machine. We know everything what actually we can get out of VMware API. And then, of course, as I said already, we have then infrastructure metrics, which includes the most used capabilities. For instance, we want to check if there is a similar service on a target site, like for vMotion, just as an example, right? In the VMware world, the people knows this term vMotion or DRS or something like that, right? And then we try to see first, before we actually start the migration, if the major capabilities we can replicate or is already there. I mean, at the planning phase, I think I don't want to go in that detail now. I mean, I spoke already a lot about it. I think important at the end is that we have defined milestones, that we have already defined a pool of test workloads, because of course, before we start with the to scale up the migration, we want to test and validate first the migration, right? So we have to define a couple of workloads upfront that we actually can test. And then, as I said, we are deploying the all involved components on target and source environment. We make sure that everything works in between. So in between means there is all ports are open for the communication, network connection, of course. Then how fast we also test the speed of the migration, what is possible. That is important for also further calculations. So we validate actually what we have discussed before in the workshop. We also validate then the numbers, the transfer numbers, that highly depends also on other criteria. I will also come later to that. And at the end, when we have deployed everything, validated everything, then we actually also start with a test of these workloads. Yes, and then the last two steps, migration validation. Migration, we start always small. So that means we are defining together with you what the first batch of migration will be, and we increase this over time. So let's say we start with in the first week, we start with 200-300 virtual machines maybe, or less. Again, depends on the agreement. And then we scale up in steps what we have defined. Validation is important to know because we cannot validate. That is very important to know because every single workload is unique. We have no idea what is running inside a virtual machine. For us, a virtual machine is a virtual machine. It's just data, right? At the end, that has to be boot and run again on the target side. So testing and validation of the workload itself is always up to the workload owner. Only the workload owner can share with us the result if everything is running like expected, because simply we don't know, right? So migration relies heavily on. Of course, we have three big parts here. That's the workload itself. So how is workload designed? Means is a monolith application, or has already split off in different parts? Do we have tier 3 application, or even a highly distributed workload like Kubernetes or something like that? Then is there already automation in place? So that means that some customers who are already prepared for such situations, maybe they can easily migrate in quotes by themselves, and we just support to shift the data. Then the deployment strategy, that is actually very close to the point before. Deployment strategy like blue-green deployment, you have already such a strategy, so it's much easier for sure to migrate. On the other hand, again, we might have a offering a warm migration. So we are syncing actually initially the data from the source to the target while the source is still running, right? There is no downtime, not even for a second. And then the customer actually on the target side can start testing when the things are done. So there are already then virtual machines, what you had already on the source side, and you can start testing. Only during the final cutover, then you have a short downtime when we migrate the final delta. Migration window, I think this is important for highly business critical applications, which don't want to have any downtime for sure. But if there is a maintenance, then for sure we have to define somehow a migration window, maybe at night and the morning, depending on the workload itself. Okay, next box, provider. Amount of workloads, amount of data, obvious, of course. The more data and more workloads you have, the longer it takes. Data center location distance. Of course, I think all of you can or know when you want to migrate data inside a data center, it's most likely much faster than if you migrate to a longer distance data center. So maybe the bandwidth is not that high in between them. So that's definitely a limiting factor. And the service dependencies, right? That's what I spoke before about the capabilities of an environment. And the infrastructure that heavily relies on the provider as well. So network throughput between the environments. And here I want to say, if you are not able to create a physical, let's say, independent link or connection between the two environments just for the migration, which is in many cases actually many cases happening, then we are using the typical north-south bridge, what is already there. But then we need to be careful not to disturb actually the running workloads. So we are starting actually limiting the network bandwidth that we can be ensure, not consuming everything, and that the source workloads are still normally running and be accessible. Storage performance and storage capacity, of course, as well. Performance, I mean, when we are migrating off from a HDD to NVMe, of course, the HDD are heavily under pressure compared to the NVMe. So this is definitely also a factor. Storage capacity, one thing here, we require for during the migration, and not for sure for the whole storage because we are not migrating everything in one batch, but for the time of migration for, let's say, tenant A, we require for this time until the final cutover, the double size of the actual data. Why is that? Because we want to provide that the customer, the workload owner, can test on the target side. For this particular case, we are keeping the original volumes in sync that we have at the end, don't that much downtime for copying the delta, but also it means that the customer can test on the target side, and therefore we have a temporarily double size of the data. The capabilities, I think we mentioned some of them already. We have end user UI or operator UI, depending how you want to offer that to your customers. If it's driven by us or by you guys, it's mainly then used also by an operator, but also it's multi-tenancy able to use, and also you can provide it directly to your end customers, the access to the platform. But again, typically the end user don't want to do it because as Michael described at the beginning, no time, no knowledge, and so on and so forth. Wall migration, obvious. Virtual machine and disks. That is really the only thing what we are currently migrating fully automatically. Of course, we can extend that. For instance, we did this for a customer that we scanned on the source environment the available networks and created fully automatically on the target side overlay networks with the same subnet and so same sitter actually, and that the virtual machines on the target side preserves the same IP address, even in theory, they would have a doubled IP address if you're using a data center network and would get in conflict. So therefore, in this case, we just created overlay networks so that the workload just can run with the same IP address. And we don't have to think about can virtual machine connect to virtual machine 2, so one to virtual machine 2 to a database or whatever with the configured IP address. So we don't have to deal with that. Everything works then like expected. There is one thing. Typically, let's say nobody wants to change the original workload. Why? Because we are not the owners. We don't want to change anything. But at one point we has to, and that is the driver replacement. We has to replace VMware drivers to virt.io. virt.io is required to for DKVM, what is the hypervisor for in our case. And that is also done fully automatically. We can migrate Linux and Windows machines. We can also increase the parallelism of the migration on virtual machine level. And of course, when it means on virtual machine level, then it's also on project level, because you are able to fully configure the project mapping. So it doesn't matter what structure you have on the source side. If your teams are structured in a cluster or in a folder, or however you cluster, you're organizing your teams, we can map that on the target side to projects then. And well, there are of course tons of other capabilities, but one thing I want also to highlight is the boot order, because that could be important for a couple of reasons. Like you want to boot, for instance, a database before the rest starts, right, of your workload. So what are we require, and where are the limitations for such a migration? VMware tools must be installed. Why? Because without VMware tools, we are not getting all the information out of the virtual machine what we require for the migration. Also, Cloud Init must be installed, or let's say should be installed. It will not be a blocker for the actual migration, right, that I want to highlight. But it is then a blocker on the target side, because your machine will not boot properly. I mean, they will boot, but you will not get, for instance, network config, right? So if it's not installed, there is no blocker, but then the workload owner on the target side has to do it manually via a typical console or something, and install then Cloud Init, and then everything is good as well. On VMware side, we require CBT enabled. It's changed block tracking. That must be enabled before we do the first snapshot, because we rely on this function that we read out the deltas and shifting it to the target then. Of course, we need a connection between two environments. I think that should be clear. We also need a SMTP server, or well, maybe not a server, but somehow that we can send reports to the operators, and of course as well to us for licensing. On the target side, projects, users, networks, actually all entities which are in this case not available in VMware, needs to be created upfront, right? Again, this can also be automated. Some of them don't need automation. In our case, with Mirantis OpenStack and Kubernetes, you actually don't need to create users, right? Users getting fully automatically created when the user log in the first time. So that's not required. But projects and everything related inside a project needs to be created, right? Especially the networks and the routers and the subnets, right? This is actually what you need. Also, security groups could be also think about to default one and use it for every workload. But something like that, everything will be discussed during the workshop and defined, right? And also, if there are requirements for additional automation, this again could be done on top. And the agent itself, that is maybe also what is required on the source side. So the agents running on every single ESXi host. What I should highlight, because that is very important, you don't have to install anything directly on the ESXi host. The agent is just a virtual machine that runs on the ESXi host and calls directly the API. Limitations. I really very quickly go through that because the time is already running here. Volume disk snapshots, of course, we cannot migrate snapshots. I think that should be clear. It's just a pointer, a time and pointer. We cannot migrate something like that. That's only possible if you preserve the storage, but then you don't need to migrate, right? So then which machines that has well, there is a function in VMware that you can share your iSCSI or SCSI bus with another virtual machine, and that is also not supported because we cannot simply create snapshot out of that. With your network policies, we have not included. Then one thing what maybe is interesting to know, we haven't had really problems with it, but in the nature of variety of workloads and also settings configuration of the virtual machines, I would like to highlight that the network adapter, so the NIC name and also maybe the device names will be changed. This is simply because of the driver replacement, right? Yes. So, and Windows-based virtual machines dynamic disk will be converted to regular disk, and VMware enabled storage replica is also not supported. We cannot. Okay, testing. I highlighted at the beginning already that we are not able really to test the workload, right? So what you're doing is we're just testing on the target side if the workload is running. I mean, not the workload, sorry, the virtual machine. If the virtual machine is running, and that is simply via OpenStack API. We cannot, as I said, we cannot perform any smoke or function tests because we simply don't know the workload, right? And to write for every workload what you migrate a test, this would take ages and would extend the migration time massively. We rely here fully on the workload owners because they hopefully, I would say, have a fully automatically test suite that it just can run against the migrated workload. Failure handling. I think that is also important topic to highlight because if someone says with a migration of 10,000 or 40,000 virtual machines, there will no issues. This is a strict lie. Of course, you always in such a scale you will face issues. This is not because of the infrastructure or the tool set. It's just simply because every single workload is unique. and every configuration is also unique. And well, operators, come to ideas to configure something just to solve the problem, which is maybe not the best way to do so. So you will run into issues, and but that is actually not the problem, because the concept that we try to have a very solid plan, also in a combination with an agile concept, that we can actually react pretty fast on failures. And the operators, or our operators, can will investigate that, will fix them, and if needed, restart the migration of this particular workload, and or support the workload to fix the issues if it relies on this side. Then when an issue happened on, now let's say on a workload side, which is actually, if so, the typical case, then the whole migration, so for the other virtual machines, will not stop. So there's no interrupt of the whole migration process if one virtual machine, or let's say one project, has issues. The other migrations, the other projects which are still migrating in parallel, they're still running. So we keep this in progress. Why? Because it doesn't make sense to stop, for instance, I don't know, when you want to migrate 8 terabyte in the night, it doesn't make sense to stop everything just because of one issue. Of course, if it's a major issue in I don't know, the connection or whatever, of course, then there is a major issue, right? That needs to be fixed immediately then. Also, the graphical interface provides you a pretty good overview of all the issues, what happened. There's also a summary, and there is a summary of at the end of the migrated workloads, issues, and so on and so forth, with a proper description. So I put also one slide just with a story here. I couldn't, and sorry for that, I couldn't add the name of the bank here, but just a couple of weeks, actually months ago, is it already? Years running fast. We migrated, it was 118 or so ESXi hosts, 300 bare metal hosts, and actually with mixed operating systems, so Windows and Linux machines. But I have to say the majority was Linux, because yeah, that is actually what we expect always. So the challenges, and that's why I want to add here. The challenges was actually not really the migration itself, because if you are in a bigger company, then you have certain restrictions, you have certain processes, what you have to follow, and all this for sure needs to be discussed during the workshop, because all this can actually extend the migration, and we should be prepared for that and plan directly around that. So, for instance, a huge problem in this company was to find the workload owners. They haven't had a clue who is owning what. They're just running virtual machines. They knew a contact, right? So there was in their system a contact for this and this project, and that's it. So the problem was that these contacts not really replied to us if the workload is running, if they're actually willing to test, and so on and so forth. So that was a bit of a challenge. And but that can only be solved for sure by the people of the company, because we don't have influence on that. But that was something what I want to highlight, because that is the governance is more a time-consuming factor rather than, well, of course, the data transfer as well, but that actually can be dropped by just simply more bandwidth and faster hardware, frankly speaking. So nevertheless, we have two parts or two streams left. This is containerization and modernization. So containerization, as Mike already said, is focusing on really to take the components, scan your current monolith application, and try to put the components which is running in a single virtual machine currently in containers and bake fully automatically a container image out of it. But it will not refactor your application in this sense, right? Because that is I think there are already some tools out there who try to do that with support of AI, but that is for sure another story. But nevertheless, it's still pretty advantage if you think about that you can easily containerize actually monolith applications, right? We have here 4 boxes with the major benefits. I think I'm not sure if I go through that all now, because let's say I hope after what is it now, 12 years of containers in this world, the the listeners here know some advantages of a containerized system compared to a monolith application. Nevertheless, I think one, or let's say two, I should highlight. That's the portability, and that is the scalability. Portability today, I think, is a big buzzword because nobody wants to rely, why we also talk here. Nobody wants to rely on a single vendor for their infrastructure anymore. So portability is definitely a big thing, and containers makes it very easy to do so. And scalability, I think it goes hand in hand. When you have application today, monolith, you have to put in the same resources, well, next to the other one, to the other virtual machine or bare metal host or whatever. And well, then you have a HA system, yes, and you have scaled, but the costs are pretty high, right? So I think, containerized system, you can just scale what you really need, so you save at the end money, and it's way faster, right? You don't have to prepare much things or something like that. You can actually, the system itself does for you. So there are for sure also some challenging aspects if you move from a traditional world to a more modern world. Let's say that. So first, I think the most obvious is the initial invests, and therefore the containerization is actually not that expensive. But the modernization, so a real refactoring of the application, is a could be a very, very long process, which is not done, well, depending also on the workload, of course, but it's not done in a week or in a month. And therefore, we highly suggest to think about it, because it's better to invest in a highly critical application to refactor it rather than see suddenly it crashes and you cannot do anything against it, or you don't have any experienced people in your company anymore that can maintain this application anymore, even it's super business critical. So therefore, that's the reason why we also think, when you think about just shifting data, you could also in the same approach thinking about, if a subset of this workloads really requires containerization, modernization, where it makes sense, then would be a good time to think about, because you can do it in one batch, right? Okay. One item maybe here when I see it as well, what I want to highlight is the learning curve, right? it is for some people a challenge, especially if you think about if someone worked for 20 years with VMware, for instance, right, and now has to let's say work with a real cloud system like OpenStack. For sure, there is a difference, and the same is as well for a developer who works on a completely maybe a different level before. So this can be a challenge, but it's also definitely on the mid and long term advantage for these persons and also for your company, of course. Okay, last slide. In summary, how do we mitigate all these challenges? Of course, I think the first thing is automation. Automation reduces the effort at all, and of course the human errors. If you do everything manually, well, the people can be experienced as they want. If you as a human type the 10,000th time the same thing, of course you could be tired, right? And of course there can be human errors. And to mitigate that, automation is the way to go. And the mapping improvement, right? That is something what also we are currently working on, that we want to improve more and more, that we can actually map what makes sense. But it's also for us a kind of learning, right? Every customer has other requirements, so and then we see what makes sense and what doesn't. Experience, I think, is also a good thing. If you if you have a contact person when there are issues, especially the plan, what we think it works with the agile approach that we have also every week meetings and sync with each other and can address something like that. It's very important that you have experienced people that really can see the issue, investigate in the issue, and fix the issue. And well, the tight planning and tight communication with the customer, I think that should be always the case. But I think in such a big scale migrations, this is a very important point, and that should not be seen as a regular topic. What what everyone says. No, it's really when you have large scale migrations, and especially they are, it's not only that you're shifting data, there are really workloads on it, and the workloads that's getting used. So you have definitely here important steps to do and to plan. Then I would say thank you guys, and I would hand over to Michael again.
Thank you, Heiko. And I think that this has been a very informative webinar, and thank you very much for attending. And I hope you drew value from it. And of course, if you have any questions, comments, concerns, or if you would like to talk to myself or Heiko or anyone within our organization, please feel free to send us an email or reach out to us directly. And thank you very much for your time today, and I hope you found value in this. Have a great rest of your day.